Welcome to the April 2021 Taste of Divine Wine Club. I've been asked to do an entertainment section, and as the regulars know, I normally do some kind of science introduction followed by some jokes. Well, I've tried, and what I've found is doing jokes without a live audience is really difficult. And rather than do a bad job, I'm going to leave the jokes till we can get together again in person. But I do have a special science presentation that I hope you will enjoy. And I look forward to seeing you all live, hopefully not too far in the future. Thank you. Good evening, and welcome to tonight's lecture on white holes. I assume you've all heard of black holes in space, infinite density and infinite gravity. A white hole is just the opposite. I have one here. A white hole has zero density and zero gravity. Of course, it's difficult to study, so I have developed a white hole detector, and now you can see the white hole. In fact, white holes are normally expensive. I bought this one in China, very cheap. Then I realized why it was so cheap. It's actually a unidirectional white hole. That is, it's not a white hole on the other side, like a true multidimensional white hole would be. And from the project I'm working on, I wanted a window that I could look out in both directions, not just one direction. So I thought, well, these are cheap enough. I'll get a second cheap white hole and put it on. And now I've got a window in both directions. The trouble is, because they're independent monodirectional white holes, they're not synchronized. So if I move this white hole, I haven't relocated that white hole. So if I want them physically synchronized, I have to move this one and then move that one. And now I can have the window in the same position, okay? Well, say I wanted two windows, two white holes on the same side. Well, I just physically move that one to make sure there's room, and I could remove the white hole from this side like that, reposition it on this side, and now I've got two unidirectional white holes on this side. The trouble is I've got no holes on this side, but you can work with that. And now I have been asked, what happens if you put a white hole on top of another white hole? Well, you would just reposition it like this on top of that one. And of course, mathematically, 0 plus 0 is 0. That's what you get. The confusing thing is, if you take 0 from 0, you've got 0. And you're back where you started. Thank you for watching. Several months ago, I made that video several months ago, and some people have suggested that maybe there was some cheating involved. And I'm really surprised as a professional engineer that that would even occur to anybody. Clearly, there's a need for some clarification. And some people had asked about the transparency of white holes. So let me just bring back the white hole detector that I've developed. And let me find a typical white hole here. And I put it on the detector. You see, anywhere within its boundary, it detects the white hole. Now, and the question is that hole transparent? Well, clearly it's not transparent from that direction. Is it transparent from this direction? Well, yes and no. I mean, it appears to be, but it's not for my hand. In fact, it's not for my head either. So we refer to that as pseudo-transparency. And the cause of that is the direction of the magnetic polarization of the hole. Now, this is magnetically polarized horizontally and vertically, so you get the pseudo-transparency. To make it a true hole, we need to shift the magnetic polarization axis to the longitudinal frame. So I've got a magnet here somewhere. Yeah, here we go. Here's a very strong magnet. It's a samarium cobalt nickel barium phosphate. And with the field being this way and that way at the moment, what you get is the pseudo-transparency. But if I use the magnet to shift the magnetic axis in the longitudinal frame, what we get then is a hole that is truly transparent. In fact, it's so transparent, I can put my hand through it. It's a real hole because of the axis of magnetic polarization. But if I use the magnet again to shift it to the horizontal and y-axis, it becomes pseudo-transparent again. So I hope that's answered any questions you may have had, and thank you for watching.